Good afternoon, class. Yesterday I talked about rate law. I touched it briefly and I feel like I didn't go over it properly. So today what we're going to do is I would like all of you in both groups to grab cup number 1. So everyone gets cup number 1. I'm probably going to need this. And I would like everyone to take a sip.
A sip?
Mm-hmm. They're really little. Sorry. And I want you to discuss amongst yourselves what is in it and the concentration percentage amongst your groups.
Is this Tropicana?
Yes.
Does it make sense? It's very hard. It's very. I would say highly concentrated. This one is. Yeah, that's why I asked. Because some other plants are like 50%. They could be like from concentration.
It's okay. So did everyone come up with a consensus? What did,
Yeah.
Everyone's in agreement? In the groups?
Yes.
Okay, so what did you guys think it was?
Orange juice.
Orange juice. How much of orange juice did you think there was?
100%.
100%. What about you guys? What did you think was in it?
Orange juice.
Orange juice?
Highly concentrated.
100%. Okay. Alright, now I want you guys to try this cup number 2. And you can, the reason why I didn't tell you to drink all of cup number 1 is because you can compare the taste. What's the difference?
Yeah.
Taste it.
And I want you guys to answer the same questions. What is in it and the concentration of what's in it. You're welcome.
Slash toilet water.
So is everyone ready to present?
Yes.
What did you guys think it was?
50%, about 50%. Well, orange juice and water, something diluted. I would say water and 50%, about 50% concentration.
Okay. And you guys? Same thing. You guys are correct. We had orange juice and water. Whoa, sorry. 50% and 50%. So if you guys were to write a reaction for cup number 2, what would you do? OJ plus H2O gives you what?
Equals OJ for H2O.
I mean, it's a hydrate. Okay. So if you look underneath, it says, what we talked about yesterday, rate law relates rate to concentration of the reactants. Does anybody know what rate is?
Something for something.
Okay, something for something. Okay, yeah. It's how fast a reaction takes place over amount of time. So I should probably write that. You guys can write that down also. In the other underneath, you see like there's a space for notes. You can totally write it down there. It's how fast something happens over time. Okay, so if we wanted to write the rate law for cup number 2, can anybody guess how to do it? It's kind of tricky, it's alright if you don't. The rate law.
Oh, it's like reaction one. The concentration of reaction to the. I know this. Isn't it the concentration of the product over the concentration of the reaction? Something like that.
Sort of. Well, okay, so let's just read this definition. It says, relates the rate of concentration of the reactants. So, if the brackets mean concentration, you were correct in that part. What are the reactants? So here you got OJ, and here you have H2O. So rate law, the arbitrary formula for that is R is equal to K, which is a constant that they experimentally discovered, times the concentration of reactant A with respect to a certain order, times the concentration of B with respect to B's order. So here, all we're missing is a K, an X, and Y. K is a constant that they for each case it changes. So that is rate law. So if you guys can look to the worksheet that I gave to you, we could look. All right, I want you to also pull out the handout that I gave you. I want you to compare them. So, because you're going to need to write your notes on the handout, okay? So, who wants to read the first question? Anybody? Huh?
Given the concentration experimentally, are the correct rate law equation proving the value for the rate constant and indicate the overall order of the reaction?
It sounds scary, right?
Yes.
Okay. So okay, part 8, what are we looking at? A reaction. So let's write that down. A2 plus B2 gives me A2AB. Okay. So if you look at the columns of what's given to you, you're going to see it says, in the little box, it says experiment number, and then it says concentration of A. That's what the brackets stand for. And then it says concentration of B. And then it says the rate. So what this means is they did 4 different experiments with different concentrations, combining different concentrations, just like what we did here. The second one, we knew that there was 50% water, 50% orange juice. Well, they just messed with the different concentrations as well. And they found out the rate experimentally. And they recorded it into this chart. So what we want to find is what is the order. The order is like how fast, the order is like how fast it decays. Well, I'm sorry, I'm getting myself confused. The order is with respect to the concentration.
Exponent.
The exponent, there we go, thank you, I'm sorry, I'm like totally lost. So, how would you calculate rate law? Well, first of all, I want you guys to look at column B, right? What do you notice when you look at column B? When you look at the numbers, do you see anything in common?
It says constant for experiment 3 and 4.
Can you say it louder?
It says constant for experiment 3 and 4.
Okay, so whenever you're trying to solve for the rate law, number 1, you want to look for similarities. So in this case, according to column B, the similarities were in experiment numbers 3 and experiment number 4. Okay? Is everyone with me so far? Okay. So the next thing you want to do is you want to look at the rate. Which value in the rate, and we're comparing 3 and 4, which value is larger? 0.36 or 0.04? 0.36. So in order to find the exponent for A, we're going to divide exponent 4 by exponent 3. I mean experiment 4 by experiment 3. So does somebody want to come up and write it up?
Right, that.
Mm-hmm. So just write all of the information here. All of it is equal to.
What is
Oh,
that equal to?
okay. Can you write the rate law for this? Can someone help him out? How do you write the rate law for this equation? Yeah, come.
Trade off.
All right.
Looks like 1 minute.
Oh wait.
Okay. Who agrees with her? 2 people. How many people agree with her? It's okay. Most of us? Okay. Alright. Well, the rate law is like this. What she did wrong, it's okay. Everyone makes mistakes. What she did wrong was that she put the product over the reactants. This is true, but it's not applicable. Well, it's true for other formulas, but not this one. What you just need are the reactants she put in the product. That's why this does not happen. So if we just get rid of this, and we put reactant A to the X, reactant B to the Y. Do you understand? So, Rob, could you please come back up here? So, this is R right here. You set it up correctly.
Okay.
So what is missing here? You can look at the information here.
A.
So A for the reaction 4 was 0.003,
That's 0.004.
0.001.
0.001.
Set it up exactly like this. So what are you missing?
K.
K. What about down here?
This.
K. Because like you see,
both
experiment number
sides,
4,
yes.
we're doing the reaction rate for experiment number 4 over the reaction rate over
Okay,
experiment
okay.
number 5. And now what else is missing?
A.
That is A.
Oh,
Look,
okay.
you got that from the A column.
Oh yeah, yeah.
So what is missing?
This.
No.
This.
Yes. And the brackets.
Oh, the brackets. And the brackets down here too.
Uh-huh.
And a Y.
X. Because these are A's.
Oh, they're both A's.
So what about B? What would you do for B? Wait, actually, let me ask somebody else.
Yeah, yeah.
Anybody else want to come? You can come. Doesn't matter. Do you want to come?
No, what, so explain, can you explain to us like what just happened?
Okay.
I see the rate, like these are K,
Uh-huh.
concentration to the X, B, with respect to Y. Now you are,
Now I'm trying to write the rate law for experiment 4 and over the rate law of experiment 3.
oh, okay.
So he did half of it. He put K, concentration of A. What is missing here?
You have to read the B.
So can somebody read that to me?
0.004.
Uh-huh. And what about the bottom?
Same.
Okay. So let me just get rid of this. What do you notice? Can I cancel anything out?
The right sides.
Why?
They're the same thing.
Exactly. Same thing for the K.
K's.
So does somebody have a calculator? Mine is over there if you want to use it. What is 0.36 divided by 0.4?
Oh, 0.11.
By,
No, it's 0.11. Oh wait, never mind. I did the other way.
what is 0.003 divided by 0.001? To the X.
X.
Don't forget the exponent. So what is X equal to? So we found out what X is. We found that X is equal to 2. So that is the order with respect to A. Is everyone with me so far? So how would we solve for the order with respect to B? Okay.
So you got for the non-equal situation, just divide each side by 3?
Well, that's an exponent. So I just did Like 3 squared gives me 9.
Oh, okay.
Okay? So, okay, let's start it from the beginning. So let's go back to the graph, the box that was given to you. All right, what did we do first to get all this information here? Look for similarities. Thank you. Okay, so let's look at column A. What are the similarities? 1, 2, and 3. Okay, so we can just pick 2 of them. Let's pick the first 2. Whoa.
I guess you want
Do you want to try it, Cesar? It's okay. All right, you guys can just walk me through it. Okay, so number 1, we looked for similarities. So we decided to choose experiments, what, 2 and 1?
Yes.
2 and 1. Okay. So which one has a larger rate? Experiment 2 or experiment 1?
2.
Experiment 2. So what we're going to do is we're going to divide experiment 2 by experiment 1. So that way we can have whole number answers. Like see here, had we flipped, had we done experiment 3 divided by experiment 4, we would have gotten like 1/9 or something like that. I don't like fractions. Keep it simple. Divide, always, number 2, divide by smaller number. So for experiment number 2, can somebody read me? So I'm just going to write the rate reaction right here. R is equal to, can somebody tell me what it is? K. Uh-huh. Uh-huh.
X.
Which is 2, we know that. To the Y. Okay, so what is the rate for experiment number 2?
0.02.
Uh-huh. Well, no, the rate. So the last column is the rate. And what about experiment number 1?
0.0.
It's K. What is the concentration for A?
0.001.
And for experiment 1?
Same.
What is the concentration for B, reactant B in experiment 2? And experiment 1?
0.001.
All right, so what can we cancel out?
K.
K's and that. So what are we left with?
0.02 divided by 0.01, which is
2. What is 0.002 divided by 0.001? 2.
1.
So y equals 1. So right there, you've just found the order with respect to A and the order with respect to B. Now, if you wanted to find the total order, you just add x plus y. So what's x? Wait, how many people say 3?
You said X plus Y, right?
Yeah. No, I'm asking, what's x? Sorry. Let me
X
split
is
this.
2.
X is 2. What's y?
1.
So your total order is
3.
3. There you go. So you just found out, well, what did they ask you in the problem? They found you
The overall order of reaction.
the overall order of the reaction. That's right here. They asked you the correct rate law equation. Well, we just change this to 1. That's the rate law equation. And what is left? K,
Rate constant.
the rate constant. So how would you solve for K?
Put everything back in, and then put your rate, put your A to the second, B to the first, and solve for K.
That's correct. So I'm just going to write it on the board. I'll leave that there. I'll do it right here. So if I wanted to solve for K, I would pick any of the experiments and literally just plug it right back in. So pick an experiment. 1. Okay, so 0.01 is equal to K. What's the concentration of A?
0.01.
.001. What is the order? To the second times. Okay, so how could I solve for K?
1.001 squared. Do you have to square it?
Mm-hmm.
0.001, and then divide that on both sides.
Divide on both sides. That's correct. So does somebody want to? This is squared and this is left alone. So K is equal to. So can someone solve for it?
Am I just dividing on the left?
Mm-hmm.
0.001.
Are both bottom things supposed to be squared?
Just one of them.
I got a very big number.
Yes.
I got like 10 million.
You're correct. So that's K. This is the rate law. And this is the total order. Does everyone understand? So would you guys like to want to go over part B? Do the same exact thing. How much time do I have left? I'm good? Okay. So does anybody want to do part B? Actually, do you guys want to work in groups to solve for it? And if you guys want more drinks, I can totally help you out. Does anybody want? Oh, let me not leave that on the floor. So where would you guys begin?
With part B.
That's true.
With finding similarities.
Experiment 2 over experiment. Oh, sorry, experiment 3 over experiment 2.
Mm-hmm.
So then we do
What did you say?
0.008.
Yes. So sometimes we start with C, right?
Just initially, it's easier to start off always like write the rate law with like to the X and to the Y, and then solve and follow it. That way you always know the order of how it works.
Let's get
Good.
C.
Yes, good catch. Uh-huh. How are you? It doesn't. Whichever. They wanted to compare. Which ones? You wanted to compare. I think they said they wanted 3 and 2. So it's easier if you write out like the total rate law with like no numbers, and then follow it and write out every step, so that way you don't get lost. Okay. How are you doing?
I think okay.
Okay. Wait, no, you started it. Keep going.
That was right?
Yeah. Is equal to.
Concentration of C.
Mm-hmm.
0.3.
Yes.
And then before.
Mm-hmm. But don't forget the X and the Y.
Always forgetting those exponents.
Just keep going. Good job. How about you?
D is opposite. Look at that. They're similar, but then these are similar too. But it'll just come out to 1. That's okay, I guess, right?
How are you doing?
We're doing all right. We're working out.
Where am I at here? 0.08, 0.08 equals K.
You're good, Intisar. Good job.
C 0.3. We already did this one to the 1, right? And 0.1 to the 1. Over here, 0.04, 0.04.
Do you understand it?
Yeah.
Oh, no. This I'm sorry.
Okay.
X, right? So that's gonna equal 1.
So, did anyone find an answer?
What?
Do you need help? Anyone?
I think I got 0
Correct.
for X.
Yeah.
Nice.
Good job. And you? How are you doing?
Good.
You found 1.
I'm sorry. Oh my God. Oh.
You don't need to include K's. Huh? Because they divide, it's K over K.
Right.
So, yeah. But you put K here. No, it's okay. It's just so that we have less to look at.
I'm not there yet.
Where are you?
Is it total 1?
Okay. So you did the rate. See, this is where you messed up. Sweet. This is the rate. This is not the concentration of C.
But you did that there. Wait.
Yeah, that's rate. What you need, well, you almost had it right here. But, so, let me put this down. This right here is the rate, which is equal to. That can't be X.
Here, but it was 1, so the whole total thing
This
was
could
1.
be X.
So what if we like this 1 equals 0.3? I'm crossing these out, but I chose this
Well,
1.
0.3 divided by 0.3 gives you 1. And 0.8 divided by 0.8 gives you.
Well, no, it's. But it's
Well, what are you comparing? Experiment. Oh, well, I'm like 2 places
oh,
at
wait,
once.
no, never mind. I'm
1
wrong.
second.
I'm sorry.
Okay, so this right here is your R.
Never mind.
You got to put in your K.
Oh, okay.
That's where you messed up. And then you put your K here, or K here. 0.03, that's for equation 3, right? Divided by 0.01. So that's the X. So what about concentration for D?
It's just 1.
0.04, the Y. So then those cancel out, your K's cancel out, and then you divide. 0.08 divided by 0.808 is what? 1. 0.03 divided by 0.01? 3 to the X gives you 1. Yeah. There you go. So now how would you do for Y? So what'd you do here? See?
Second one.
3 to the X. That's correct.
It's 0?
Isn't it? Yeah.
Yeah, isn't it? I don't know. I need to calculate.
Oh, because for math? Yeah. 3 to the 0 equals 0. It's alright. Yeah, it's tricky. So how would you do the second part?
Oh, okay. So I guess 2 and 1.
Why is there such a large number? But then we had different reactions here. Yeah, we had different reactions too. That's what
Yeah?
Can we check and see if we did this one right?
Yeah.
So we got the total order was 1.
Yes.
We got the reaction was R equals K, C to the 0, and D to the 1. And then we actually got the K was 2 times 10 to the negative 4.
2 times 10 to the... It says 2 times 10 to the third.
To the third.
So what'd you do?
When you do the rate, you just choose
Huh?
this, right?
You okay?
I'll tell you.
Okay.
When you do the actual rate, solving for K, you choose a rate, right? Then you choose a corresponding C, a corresponding D.
So which one did you pick?
This.
Wait, which one of these? I'm sorry.
0.02.
Experiment. Did that one, the first one? Okay.
Yeah, so
So 0.02 is equal to K.
And then
0.1 to 0.
0.01 to the 1. And then K would be that divided by this.
0.02 divided by
Did I plug it in or not? 1. 0.1 to the 0 is 1, right? Anything to the 0 is 1, no?
Yeah, I don't know. 1 to 0.
Maybe
I
that's
forgot.
wrong, maybe.
It should be, yeah, it's 1. Yeah.
Okay, so
0.02 divided by 1 times
0.01.
0.001?
0.01.
Yeah. You got 2. Whoa.
That, what?
2 times 10 to the third.
0.02 divided by 1 times, okay, and you got 2 and yours is
0.02 divided by this times this. 1 times this to the first.
Yeah.
Oh, that's why. I didn't put to the 1. I'm not sure if that makes a difference. No, it doesn't. 2 times 10 to the third. Divided by the concentration of D, 0.01. 0.02 divided by 0.01. I don't know what they did. You're right. The answer is 2. I don't know where you got 2 times 10 to the negative 4.
exactly. Why? That's because we said one is was so big and then one is so small. I'm not familiar how to work with his math calculator different than me.
Well, because the reason why is because we're completely ignoring the concentration of C. It's based on concentration of D and the rate law.
Okay.
That's why it's so small.
Okay.
Okay. Yeah.
All right then. So can we stop here?
Yeah, you guys are done. We're just gonna go over the problems, the answers. All right, guys. So how are you guys doing? K is equal to 2. Yes.
Yep, that's what we got.
And Y is equal to 1.
Yeah.
Yes.
And what is X equal to?
0.
0.
Okay.
Overall is 1.
Yeah. So everyone got the right answers. You guys can work in groups to finish solving the worksheets, and whatever you don't finish is homework. So, and if you don't finish all of it, don't worry, you have a little bit before, but I wouldn't procrastinate. Try to do as much as you can. And yeah, that concludes my lesson.